Example 4. In example 11.8.3, we saw that the Bessel function big J sub naught open x close, or big J sub naught of x, equals the sum from n equals 0 to infinity of open -1 close to the power n times x to the power 2n over 2 to the power 2n times open n factorial close to the power 2 is defined for all x. Thus, by theorem 2, J sub naught is differentiable for all x, and its derivative is found by term differentiation as follows. The J prime sub naught of x equals the sum from n equals 0 to infinity d over dx times open -1 close to the power n times x to the power 2n over 2 to the power 2n times open n factorial close to the power 2 equals the sum from n equals 1 to infinity of open -1 close to the power n times 2n x to the power 2n minus 1 over 2 to the power 2n open n factorial close to the power 2. Example 5. Just keep that. Express 1 over open 1 minus x close squared as a power series by differentiating equation 1. What is the radius of convergence? Solution. Differentiating each side of the equation, 1 over 1 minus x equals 1 plus x squared plus x cubed plus ellipsis equals the sum from n equals 0 to infinity of x to the power n. We get 1 over open 1 minus x close to the power 2 equals 1 plus 2x plus 3x squared plus ellipsis equals the sum from n equals 1 to infinity of n times x to the power n minus 1. If we wish, we can replace n by n plus 1 and write the answer as 1 over open 1 minus x close squared equals the sum from n equals 0 to infinity of open n plus 1 close times x to the power n. According to theorem 2, the radius of convergence of the differentiated series is the same as the radius of convergence of the original series, namely big R equals 1. Example 6. Find a power series representation for the natural log of open 1 plus x close and its radius of convergence. Solution. We notice that the derivative of this function is 1 over open 1 plus x close. From equation 1, we have 1 over 1 plus x equals 1 over 1 minus open negative x close equals 1 minus x plus x squared minus x cubed plus ellipsis. The absolute value of x is less than 1. Integrating both sides of this equation, we get the natural log of open 1 plus x close equals the integral from 1 over 1 plus x dx equals the integral of open 1 minus x plus x squared minus x cubed plus ellipsis close dx equals x minus x squared over 2 plus x cubed over 3 minus x to the 4th power over 4 plus ellipsis plus big C equals the sum of n equals 1 to infinity, sum from n equals 1 to infinity of open negative 1 close to the power n minus 1 times x to the power n over n plus big C. The absolute value of x is less than 1. To determine the value of big C, we put x equals 0 in this equation and obtain the natural log of open 1 plus 0 close equals big C. Thus big C equals 0, and the natural log of open 1 plus x close equals x minus x squared over 2 plus x cubed over 3 minus x to the fourth over 4 plus ellipsis equals the sum from n equals 1 to infinity of open negative 1 close to the power n minus 1 times x to the power n over n. The absolute value of x is less than 1. The radius of convergence is the same as for the original series, big R equals 1.